The whole idea behind the formula for the length of a line segment really is Pythagoras' theorem. Indeed, consider the xy grid I'm drawing right now, so that's x, and this axis here is y. And let's say I have 2 points, a point P right here, and a point Q right here, and we're interested in finding the length of the line segment PQ, which, by the way, is equal to the distance between these 2 points. Well, the whole idea behind the length of a line segment formula is to consider 2 things. First of all, the horizontal distance between these 2 points, so that would be this distance here, and the vertical distance between the 2 points, so that distance there. And I'm sure you can appreciate that since this is horizontal and this is vertical, the triangle this forms is a right angle triangle, where the right angle is right here. With that in mind, if I go ahead and call the side length PQ capital C, this side length here capital A, and the side length down here capital B, then we can use Pythagoras' theorem to state that the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. In other words, C squared equals to A squared plus B squared. And so applying the square root, the length of the line segment, which would equal to C, is equal to the square root of A squared plus B squared. And I'm pretty sure you're comfortable with that. Okay, now that we've established that, let's go one step further. So I'll draw another xy grid. That's x, that's y. And again, I'll take 2 points, so P, and a point Q over here. And this time, I'll actually give points P and Q coordinates. And so these will be generic coordinates, x and y. But for the sake of distinguishing these 2 points' coordinates, I'll call the coordinates of point P x sub 1, y sub 1, and the coordinates of point Q x sub 2, y sub 2. Okay, now once more, we're interested in finding the length of the line segment PQ. Well, the approach will be exactly the same as what we saw over here. Indeed, we'll consider the horizontal distance between these 2 points, as well as the vertical distance between these 2 points, which forms the right angle triangle we can see here. And since we have a right angle triangle again, once more, the approach for finding the length of the line segment PQ is to use Pythagoras' theorem, as we did up here. So what are these other 2 side lengths equal to in terms of the coordinates of these points? Well, this horizontal side length will be equal to the difference between the 2 x coordinates of the points. So this side length at the bottom here will equal to x sub 2 minus x sub 1. And the vertical side length we have here, well, that will equal to the difference between the y coordinates of the 2 points. So this side length here is equal to y sub 2 minus y sub 1. And so with these 2 side lengths in mind, we can apply Pythagoras' theorem to state that PQ squared is equal to the sum of the squares of the other 2 side lengths. So that would be PQ squared equals to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And now applying the square root to both sides of this equation leads to PQ equals to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And all of that's under a square root. And as such, that's the formula for the length of a line segment. Or we could also say it's the formula for the distance between the 2 points. More generally, given 2 points, one with coordinates x sub 1, y sub 1, and the other x sub 2, y sub 2, the distance between those 2 points, which I'll call d, will equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And all of that's under the square root. And that's the formula. Okay, well, to finish this, let's quickly see how this formula works with an example. And before I do that, though, let me add some titles here. Up here, I'll write formula. There we go. And over here, I'll write example. Example. Okay, well, again, let's say we have an XY grid, which I'll quickly draw something like this. There we go. That's X. That's Y. And let's say I have a point here with coordinates -1, 2, and a point somewhere up here, which I'll say has coordinates 3, 5. And of course, we want to find the length of the line segment joining those 2 points, and I could also say we want to find the distance between these 2 points. Well, of course, we could dive right in and use this formula right away, and in fact, I'll start by doing that. Let's say the point on the left-hand side with coordinates -1, 2 is the point I'll call x sub 1, y sub 1, and the point on the right-hand side with coordinates 3, 5 is the point I'll associate with the coordinates x sub 2, y sub 2. Well, in that case, using this formula, we can go right ahead and state that the distance between those 2 points is equal to the square root of, so that was x sub 2 minus x sub 1, so in this case that will be 3 minus -1. And if I write that, remember that's in parentheses, so that's 3 minus, in parentheses, -1, and of course that's squared, plus y sub 2 minus y sub 1. So that's the y coordinate of this point minus the y coordinate of this point. So that's in parentheses 5 minus 2, and again that's squared. And all of that's under the square root. Now 3 minus -1 turns into 3 plus 1, so this turns into 4. Okay, so we have this equals to the square root of, in parentheses, 4 squared, plus 5 minus 2, which is 3, and of course that's still 3 squared. And I close that square root. I carry on. 4 squared is 16, and 3 squared is 9. So this turns into the square root of 16 plus 9. And since 16 plus 9 is 25, this quickly turns into the square root of 25. Finally, since the square root of 25 is 5, we can state that the distance between those 2 points is equal to 5. And that's the answer. And to convince ourselves that that formula works, let's quickly illustrate the fact that all this is Pythagoras' theorem with our line segment up here. Indeed, looking at the 2 points we have, the horizontal distance between them is this length here. The vertical distance between them is this length here. And that, of course, forms a right-angled triangle. And now looking for the lengths of these 2 side lengths, well, this horizontal length is equal to the distance from -1 to 3, which is exactly what we get when we subtract -1 from 3, which is what we did here. Remember, 3 minus -1 gave us 4, which is what we had here. Similarly, the vertical side length we have here, well, its length is equal to the distance we have to go through to get from 2 to 5. And that distance is equal to the difference 5 minus 2, which is what we had here, which of course is equal to 3. So that's just 3. And so labeling that blue line segment D, as in distance between the 2 points, we could quickly state at the top here that D squared equals to 3 squared plus 4 squared, that's Pythagoras' theorem, and therefore D is equal to the square root, so square root, of 3 squared plus 4 squared. And since 3 squared is 9 and 4 squared is 16, just as we had down here, we find that the distance D is equal to the square root of 25, so that's equal to the square root of 25, which, as we've just said, is equal to 5. And this 5 shows us that whether we use the formula approach or whether we approach this whole problem using Pythagoras' theorem, we get exactly the same result, which is simply due to the fact that as such, this formula is nothing more than Pythagoras' theorem. And there we go. That's it for this video on the length of a line segment or distance between 2 points formula.